Good morning, everyone, and I'm happy to have you for this webinar organized by Fondazione Enrico Mattei. It's a pleasure today to have the possibility to discuss the net zero option and to have our guests and to friends, Dr. Laura Cozzi from Paris and Dr. Jorge Blazquez from London. And I think Professor Galeotti will be the coordinator of the session. So without, I can give him the floor to start immediately. Thank you, Marzio.
Good morning, everybody. Also from me. And thank you for being here to attend this webinar, which is devoted to a discussion of net zero emission scenario. Just 2 words by way of introduction. Net zero emissions is the new mantra. Everybody in the community is talking about this aspect, which basically is one realization, if you want, of the full decarbonization which science, the IPCC in particular, is telling us is necessary in order to limit the increase in temperature to 1.5 degrees. What, as I see it, is good about or is interesting about the net zero emission scenarios is the fact that with it, we have both an information of how much and by when, because the net zero emission scenario entails going down to zero emissions, net emissions, by 2050. So we have a time limit, a time horizon, and we know also where we have to go in terms of emission reductions. Obviously, there are several ways of going there. So we know what is the end of the road, but there are different trajectories, possible trajectories to get there. And this is exactly the reason for this webinar, because an international organization like the International Energy Agency recently released a report explicitly devoted to this issue. And, you know, there was a lot of discussion and debate within the community about what were the implications of reaching the net zero target according to the IEA. At the same time, BP, in their well-known energy outlook, included this year a net zero emission scenarios in their, you know, analysis of, you know, the decarbonization. So, as I said, this is the reason for this webinar, and we are very happy and delighted to have here Laura Cozzi from an International Energy Agency to illustrate. I think the idea is to have 20 minutes in the presentation, who will be followed by Jorge Blazquez, who is with the BP, who will talk instead of the net zero emission perspective from the point of view of BP. I have nothing more to say, and without further ado, I will ask Laura to go ahead. Thank you very much.
First of all, I say something in Italian. Un grande ringraziamento ad Alessandro e a Marzio per avermi invitato. È un grandissimo piacere essere qui con tutti voi. Un grazie alla FEM. I'll switch to English here and start the presentation. So as Marzio mentioned this, we at the IEA 18th of May this year, we produced and released our first analysis, comprehensive analysis on what does it mean for the energy sector to reach net zero emission by 2050. With no surprise, I'll tell you that it created a lot of echo from all the stakeholders around the world, and the type of feedback has varied from embracing this wholeheartedly to complete hate. So you have had the full spectrum of emotions attached to this report. So Marzio mentioned IPCC. IPCC came out last month in August with another stark reminder of actually that even 2 degrees is not enough, will bring to catastrophic consequences. Here what I'm doing is comparing our own net zero by 2050 scenario, which actually is compatible with limiting emissions to below 1.5 degrees. How does it compare with comparable net zero emission scenarios that the IPCC produced 2 years ago? And this is just a snapshot to give you a bit of the ideas of what tools we used. What you can see here is that compared to the comparable IPCC scenarios, we are using less carbon capture and storage, less carbon dioxide removal, and less bioenergy. I'll pause here for 1 second and explain you why. CCS, compared to 2 years ago, didn't do much better. In fact, projects have been stalling. So our own assessment at the IEA is that while it remains an important technology, its role in the power sector has diminished very considerably and is basically used only in a bundle of sectors mostly related to industry and oil and gas extraction. Carbon dioxide removal, we are a bit more optimistic than we were a couple of years ago, but still we don't see as large as need than the IPCC report has seen. Bioenergy is one of the areas where, we always go to peer review to get feedback by a number of experts and stakeholders. It was probably the most debated area of this scenario. 2, I have to admit my surprise, but especially in Europe, bioenergy, the amount of bioenergy that doesn't collide with biodiversity and food supply, it has become a huge issue. So a couple of years ago, it was thought that the level of sustainable bioenergy potential was around 150 exajoules. We are now talking 100 as being the absolute maximum, probably is going to be below that. So that is the reason why we actually have a bioenergy supply that is lower than basically anyone else. Here I've just told you all the options that we have reduced or kept out the table. On the other hand, we have pushed more some others. Hydrogen-based fuels, including ammonia, for example. The amount of projects that we have seen in the pipeline over the past 2 years has increased tremendously. So we are quite on the optimistic side, of course, to be proven in the years to come. Wind and solar on the high end, and the fact that you see a low total consumption there is explained by 2 things: higher degree of electrification than some IPCC scenarios and a slightly higher degree of energy efficiency. So this is a bit the assumptions that are coming in, if you want. What are the results? First, I'd say is a positive finding, which is the following. You need to do a lot in this decade to 2030. However, this a lot is all with technologies that we know and have already. Mostly electrification through solar and wind, quadrupling what we are installing today. Now, the quadrupling is something that the solar and wind industry have already done over the past decade. Of course, here we're talking about a different scale, but at the same time, we are talking about very different costs than the past decade. So whether this is in the realm of reasonable or not, I'll leave it to you to decide, but it's something that the industry has already done and the costs are coming down very quickly. Second thing that you want to push is you decarbonize the power sector first. At the same time, you accelerate on electrification. Clearly, electrification of transport is one of the avenues. Here, I give you the number of electric vehicles. The latest data for the first quarter of 2021 globally are actually 6% of car sales globally were electric. Here, we're talking about getting to 50% by 2030 is huge. If you stack up what all car manufacturers have been pledging, you actually come at around half that level. And all this transformation of getting to a few millions to actually around 30 million by 2030 plans in the pipelines today, again, happened in the span of just a couple of years. Of the major 20 OEMs in the world, which account for around 80-85% of car sales globally, 18 out of 20 and now several offering of EVs. Third critical point, energy efficiency. Here we are showing it as energy intensity improvements as an indicator. Two key areas to push there. One is actually for the poorest. You get away from very inefficient fuels like biomass, and this brings you in a lot of efficiency improvements basically automatically. The same does electrification actually. Electric car vis-a-vis an ICE, you have a factor 2 to 3 in terms of input needs. Similarly, a heat pump compared to a boiler. But there are also real energy efficiency needs, for example, buildings retrofits. So the summary of this slide is you need to do a lot this decade, but is all with technologies that we currently have. Now, the question mark is how much money do you need and would we be able to finance this? What you need in terms of scaling up investment, you see it in this slide, is a more than tripling over clean energy investments that have happened over the past 4 years. This is huge. And it's huge because it entails not only installing solar and wind, it entails what you see there, energy infrastructures. It's grids, but it's also things like starting rolling out hydrogen pipelines, CCS pipelines. While we are seeing advanced economies using the post-COVID crisis and the low capital costs directing very clearly in Europe, this is happening with the Fit by 55, being directed in energy infrastructure, low carbon infrastructure. This is really not happening in the emerging and developing world, where most of this increase is actually supposed to happen. So for us, a major fault line in what may happen over the next 10 years is making sure that the capital for the low carbon technology is made available in emerging and developing countries. Currently, the data suggests that this is not happening. So it's not about the technology being there, it's about the financing in emerging technology, in emerging countries being there. Analysis that we have done with the International Monetary Fund is that if we were able to mobilize this amount of money, there would be a net positive GDP impact for the world. Of course, not everyone would win. You would have especially coal and oil producing countries that would suffer from this. So if we look at very clearly linked to the suffering of oil and gas and coal exporting countries is the job angle of this transition. Currently today, there are around 40 million people employed in the energy sector globally. If you are able to move to net zero or to a trajectory that is compatible with net zero, so you are able to triple investment in the low carbon technology, you would be able to create just in direct energy jobs around 14 million new jobs, but you would have potentially job losses concentrated in coal community and gas community. Now, even if normally you hear a narrative of yes, but there is a net positive gain, is actually here like the story of we are all eating a chicken while one person is eating 2 and another one is eating 0. So you would have 5 million people that you need to take care of. And those are not necessarily the ones that will get the job in the electricity grids and electricity sector. So we are working quite closely with a commission that is looking at just transitions and very clearly, particularly for coal and oil workers that communities that may be adversely impacted by the transition. So there is a job losses issue that needs to be tackled head on to be successful. And there is another issue, which is skills. The skills that we currently have in the energy sector and the colleagues and young people that we are preparing in universities now, they don't have necessarily the pipeline of skills that we would need in the transition if we were to be able to use the 14 million new jobs that are potentially there. We are not preparing, in particularly, what you see there, what we call a high level of skills for new workers. This is not, again, a problem in advanced economies. It's a problem mostly in emerging economies where we are not creating the pipelines of to take advantage of the jobs that can be created. Now, the story of the clean energy transition of going to net zero is really two different chapters. Is the first chapter of the next decade that is one of being able to finance the technologies we have, but then there is a different phase afterwards, which has to do with harder to abate sector and has to do with innovation. So if you look at where by emission type reduction, where the reduction is coming from now to 2050, you see that half of the reduction is coming from technologies in the market, which are the ones that we mentioned earlier, solar and wind. You may have nuclear lifetime extension. You may have electric vehicles, efficiency, etc. But you have a full another half of that, 46%, which are technologies that are not in the market yet. They are demonstration scale, lab scale, and what are those? Here I'd like to mention basically three that we think are absolutely essential. In all the scenario analysis and sensitivity analysis we made, we were not able to reach net zero if those three are not there. First is hydrogen and hydrogen-based fuels. The reason being that even if you try to electrify as much as possible, we do not manage to electrify completely our economies. So you need a clean fuel transition happening at the same time with the electricity transition. And hydrogen offers one, not the only, but one of the avenues to go for cleaner fuels. Second is advanced batteries. We see advanced batteries becoming very ubiquitous in the energy systems. They are used to balance the electricity sector that becomes incredibly variable. I'll come to that in a second. We are using it back of the meter at homes. We are using it in our cars. We are using it in the scooters. You're using it increasingly in trucks. So advanced batteries become critical and a variety of applications. So they are really a technology family as much as hydrogen-based fuels are a technology family. And finally, we have identified actually direct air capture and the capture side of CO2 as another family of technologies that is essential, is a bit our insurance policy for the future. If you are not able to materialize all the emission reduction in this decade, you need negative emissions in the future in some form, being bioenergy with CCS, being direct air capture, or being any other form of negative emissions coming as of 2050. So two stories, one to 2030 is deployment and investment, and the second one is innovation. If you ask us if you're seeing the level of innovation needed to get to the level of deployment that we would need post 2030, currently is clearly not the case. Now, what kind of energy sector are we going to see if we manage to do this transition? Well, it's an energy sector that has some of the same security concerns that we have today and some new ones. One that is the same or similar has to do with oil. Many people tend to think that net zero is associated with zero oil by 2050. Is not the case. In our net zero scenario, you still have some oil used by 2050, but importantly, you have the role of certain countries, in particular OPEC countries, that remains, in fact, becomes even more important. This has a number of geopolitical implications, obviously. So for us, energy and oil security is not going away. However, there is a security of critical minerals that emerges as a critical concern. Here you see some of the critical minerals that are needed for the transition, and those are used where? They are used, for example, in the cables for electricity. They are used in electric cars. They are used in the renewable technologies. And all of those, here you just see that they increase a lot. What you don't see here is that they are incredibly concentrated. So the supply of those minerals, while the resource is not an issue, very much like oil, the resource has never been an issue, is where they are located may pose a bit of bumps going forward if we want to have a smooth transition. So for us, this is a second axis in which the energy security considerations are moving and moving pretty quickly. I don't have to mention that many of those are actually also minerals that are used in defense technologies. So there are, again, geopolitical implications that are attached to this. Third pillar here becomes electricity. Electricity security becomes, to be honest, more important than oil in terms of costs to societies. You are talking about societies where the level of electrification is huge. And if the network goes down, you start having GDP losses, economic losses immediately, and they are very high. So there are a couple of things that happens to the electricity sector. You have huge amount of variable renewables that come in. So you need to be coping with the flexibility needs. So ×4 compared to today to match supply demand at all times. So if you want to keep the electricity security level at the levels we have them today, it's going to be costly. But we will want it, if even not more, because we are talking about societies that are going to be even more digital and even more dependent on electricity than today. So are all countries being ready to face this? Not really, especially because if you ask me, even in Europe, we are not really getting ready to design the markets to make sure that the flexibility investments are there when we want them. So there is a flexibility story. And another flip side of this that we have been seeing over the past several months is the resilience of the electricity networks. We are going into a world where extreme weather events, being heat waves or being hurricanes or anything that is related to implications of extreme weather events are becoming more and more, will become more and more frequent. But we haven't really resilient proof our electricity systems. So this has to become much more in the heads of our policymakers to make sure that the investment signal go into that direction. So I conclude with this slide, which is probably the one that has created a lot of love and hate. So the origin of all the study was to make clear to everyone, if we want to reach net zero by 2050 for the energy sector, what does it mean? The 1.5 number, magic number, was in the discourse of everyone, but really, even for us, it was not very clear what were the implications for the energy sector as of today, for the next 5 years, for the next 10 years, etc. And what we have identified is also over 400 milestones. Here there are some. On our website, you will find all of them by sector over time. 90% of those are actually demand related. It's something that you need to do to change consumer not only behavior but habits. What you buy next in terms of your air conditioner, what do you do with your home, how do you produce electricity. However, the two that have created the big echo in the press and the emotions I mentioned earlier are the first one for 2021. The first is the following. It has to do with coal. There is no place for new unabated coal plants approved for development after the ones that are being constructed if you want to comply with this roadmap. Simply, there is not enough space for emissions there. The second is about oil and gas. And what we find is the following. If you put in place all the demand measures, then for oil and gas, the implication is that you would need no new oil and gas fields approved for development. Now, there is an important consequence here. So what is the causality is that if you put in place the demand measure, then you don't need the new oil and gas fields approved. So I will leave this here. It's daunting. However, at our end, we felt it was time to make everyone understand if we want to meet this challenge, this is what needs to happen in a very dispassionate way. Thank you.
Thank you very much, Laura. The message it was pretty clear. Let us now immediately switch to Jorge, who's a senior advisor for the energy transition and systems analysis at BP. Jorge, the floor is yours.
Thank you very much. Thank you to the Fundazione for the invitation. It's a pleasure and an honor to be here. And thank you to Laura for the great presentation. It's full of really valuable insights. I mean, the last slide is fantastic, to be honest. So my presentation today, I'm going to present the BP Net Zero Energy Outlook from something that we produced in year 2021. But I'm going to compare our scenario with the IPCC scenarios, with the scenarios produced by the Intergovernmental Panel of Climate Change. And the idea of this presentation is to share with you what we know, what are the common characteristics of this type of scenarios. So let me start the presentation. Before, a little bit of housekeeping. What is the BP Energy Outlook? Well, in this chart, you can see the level of emissions, of CO2 emissions, and three different lines. So the blue line represents historical emissions. The green dotted line represents emissions in a scenario that we call business as usual, where technologies, policy preferences, and policies evolve in a matter which is consistent with the recent past. And you can see here that there is a decline in emissions, but this is quite small. So in this scenarios, emissions pretty much stay flat. And there are two more scenarios, one represented by an orange dotted line, which is called rapid, and the blue line, which is called net zero, which both are consistent with Paris Agreement. In the first scenario, in the rapid transition scenario, emissions decline by 70%, more or less between now and 2050. And this is consistent with a change in policy, in particular with a substantial increase in carbon prices, which are the main driver of this scenario. In developed economies, carbon prices achieve $2,050 per ton. In emerging economies, 175. And the message here is that we have to penalize, we have to put a price in emissions. Net zero has the same level of policies, but some behavioral changes that recognizes that to achieve net zero emissions by 2050, apart from changing policies, we need also society to be involved. So these are the three scenarios that we have. These scenarios are not a forecast of the future. We know we cannot predict the future. They try to design or to show what are the uncertainties that are related with the transition. The second comment of before entering the presentation is, when I speak about emissions, what I am talking about. If you look at the left-hand side, the chart which is in the left-hand side of the screen, you can see the current level of CO2 equivalent emissions, so greenhouse gases emission. The blue area represents emissions from energy, which are around 70% of emissions. The BP Energy Outlooks model and concentrate only in this type of emissions. Around 1/3 of emissions are not related to energy. I'm not going to talk about them, but they are important to achieve net zero, because net zero has to do with all level emissions and not only with emissions from energy. In particular, you can see that there are agricultural emissions, industrial processes, there is emissions from waste, and also from land use and forestry and fugitive emissions, which are outside the scope of study. In the right-hand side of the slide, you can see a chart where I break down the level of emissions from energy use. And you can see three big different groups. Red represents energy emissions from industrial activities, which are 50% of total, and blue and pink represent emissions from transport and buildings, commercial and residential, which represent around 25% each. Also, you can see that some of these slices are marked with something called harder to abate. So those activities that in general terms can be easily electrified are considered easy to abate, but some activities like, for example, iron and steel, cement, aviation, marine, medium and heavy road are activities which are more difficult to decarbonize, because in general terms they are difficult to electrify, and this is going to have an impact on the rest of the presentation. Now, once I have done this housekeeping about what is the energy outlook and what I'm going to speak about, let me start with the presentation itself. So what we do know and what we don't know about energy systems in net zero. So what I'm going to do in this presentation is to compare BP net zero scenario with ICCP scenarios at the point in which they reach net zero. So here you can see emissions in this chart from the IPCC scenarios, so different level of emissions. I'm going to select the energy mix and the composition of the energy system of each of these scenarios in the moment they reach net zero. So if a scenario reaches net zero in 2070, I'm going to take a picture of that scenario and I'm going to compare that with other scenarios that reach net zero in different moments in time. 2045, I think, is the first one reaches that reach net zero. 2050, BP, for example, reaches net zero around 2050. So this is going to be the comparison. So I'm going to compare energy systems reaching net zero, but the comparison point is going to be different in time. So what is the first common characteristic of these scenarios? You can see here, and all the charts are going to be identical, the share of electricity in final energy. The bar, which is in a purple color, represents the minimum and the maximum, so the range of these scenarios at net zero. The black line represents the average of the IPCC scenarios, and the dotted blue line, the dotted point, represent BP net zero in 2050. So the first message here is that we are going to move. I mean, scenarios in net zero represent a world in which there is a massive increase in electrification. The current level of electricity in final energy is around 22%, and in the worst case scenario, this is going to multiply by 2. So it's going to increase from 22 to something between 42 and 72%. So this is the first key message: massive increase of electrification. Remember that I said before that some activities are easy to decarbonize because they are easy to electrify. And how are we going to provide the supply for electricity? Well, Laura explained this in her presentation. Wind and solar are going to provide most of this electricity. The share of wind and solar today in electrification is around 7%. And we can see that this is going to move from 7 to something between 40 and 85%. BP is in this scenario have a penetration of around 65% of total electricity produced using these technologies. Something which is less clear from these scenarios is how are we going to balance the power sheet. So apart from wind and solar, with other technologies are we going to need to provide supply to the electricity system? Because a common characteristic also of these scenarios is that at net zero, the electricity system is fully decarbonized. Not fully decarbonized. In most of the cases, the electricity system also have negative emissions to offset emissions from those hard to abate sectors. So another common characteristics tend to summarize this slide is electrification plus massive increase in wind and solar technologies. Well, what else? I mean, what happened with those technologies or those activities which are not easy to electrify? So we need something different. And something that we think is going to have a critical role is hydrogen. I mean, hydrogen for energy purposes today, it's practically zero. And in the IPPC scenarios, we see that the share of hydrogen in total consumption moved to something between 3% to 12%. This is represented by the pink bar, which is at the very beginning. The BP scenario has a much higher share of hydrogen in total final consumption, and probably the reason for this discrepancy between BP and the IPPC scenarios is that the need for this hydrogen as a solution for net zero is something which is quite recent. It's something which really has emerged in the last 3 years. And some of these scenarios of the IPPC are older, so they don't really acknowledge this need for hydrogen as a carrier for net zero. Let me explain. If you pay attention to the bar which is in the middle, where we can see the breakdown of hydrogen between sectors, you can see that industry and transport almost represent 70% of the final total demand of hydrogen. There is a little bit for buildings, and also we think that hydrogen is going to provide some of this flexible, which is needed in the power sector to balance the intermittency of wind and solar. The last bar, which is broken into 2 colors, green and blue, represent the share of blue hydrogen and green hydrogen in the generation of hydrogen. Green hydrogen is basically hydrogen which is produced using renewable technologies. Blue hydrogen is mostly hydrogen which is produced from natural gas, and emissions coming in this process are captured using CCUS. Well, why we see there is a role for blue hydrogen here? Because for example, if you follow the European Commission, it's putting all the emphasis in green hydrogen, in particular hydrogen with electrolysis, or hydrogen with produced by electricity, renewable electricity. The reason for this has to do with the deployment of the actual demand of wind and solar technology. So, as I said before, the easiest way to decarbonize the energy system is through electricity and through wind and solar technologies. But the level of investment or additional wind and solar that you need to achieve this fully decarbonization of the power system is really high. In this chart, you can see again the level, the increase in wind and solar capacity every year, which is this blue dark line, which is at the beginning, and then 3 different lines. The dotted green light represent the increase in deployment in wind and solar in business as usual, and the blue line, which is the top, represent the deployment of wind and solar in net zero scenario. As you can see here, you have to multiply by a factor of basically 5 the level of deployment to achieve the full decarbonization of electricity. We have run an experiment saying that, well, what happened, or what is the level of additional wind and solar needed if we want to produce hydrogen using only green hydrogen, so renewables? Well, this is the answer to that question, and you can see that there is a significant increase in the amount of wind and solar needed to have hydrogen produced only with renewable technologies. This is net zero with 100% green hydrogen. To achieve net zero, it's already a challenge which is going to require a significant change in the way we produce electricity. We think that there is a role for blue hydrogen because we think that this is going to make the energy transition easier. So this is a reason why we see a role for blue hydrogen in these technologies. Well, what else apart from blue hydrogen? Well, the other question is bioenergy. Bioenergy is around 2% today of primary energy, and all these scenarios assume that there is going to be a massive increase penetration of bioenergy. So the first bar that you can see here is the green line, and you can see that IPCC scenarios saying that bioenergy has to multiply by 2 in the less optimistic scenario if you want, and by a factor of 9 in the most optimistic, so between 4 and 18%. Again, we think that biomass has an important role to play. It's around 9% of penetration is going to be biomass of total primary energy. And in particular, and let me pay attention to the bar which is in the middle in purple. We see that biomass is going to play a significant role in power, helping to balance the power system. Biomass, which is the last bar that you can see here, is precisely the most demanded type of biomass. And this has to do, sorry, with negative emissions, which I'm going to explain right now. So significant increase in hydrogen, significant increase in biomass, and in particular, significant role for biomass in power. Well, what is the role of natural gas in this scenario? So is there any role for natural gas? I mean, today, the share of natural gas in primary energy is around 24%. Net zero scenarios see a substantial decrease in the role of natural gas. So you can see here that the average share of natural gas in primary energy is around 9%. So from 24 to 9% is a significant decline. Depending on the scenarios, you have something which has something around 19% or 4% in the IPCC scenarios. What we think it is important, and I'm moving to the second chart, which to the second bar, which it's represented in blue, and this white and red bar, is that natural gas has to be used in combination with carbon capture and storage. BP has a 30% of the penetration is going to be primary energy, but around 70% of natural gas has to be used with carbon capture and storage. So we see very low role for natural gas when natural gas is unabated, which is what you can see in this red area in this chart. So decline in natural gas, yes, important, from 24 to something around 10%, and in combination with carbon capture and storage. In the case of oil, oil represents around 1/3 of total primary energy today is oil. There is very little role for oil in the IPCC scenarios and in the BP scenarios, something around 7%. This is represented in this green area. And most of them is going to be used, at least 50% is going to be used in non-combustible activities. So it's going to be plastic or petrochemical industry. So the message for oil and gas of these scenarios and the BP scenarios, also the IEA, it's clear. All scenarios see a significant decline of these two fuels. It is true that natural gas is much more resilient, in particular because we can combine natural gas with carbon capture and storage. But here we have a different view I think, from the IPPC. This is the consumption of oil and gas in these three scenarios: business as usual, rapid, and net zero. And there is an additional line, which is this dotted line in black, which represents the production of oil and gas if no new greenfield investments are implemented. So I think the message from this slide is clear. So it is true that there is going to be a significant decline in the consumption of fossil fuels, in particular oil and gas. It is true that in the particular case of oil is going to be aggressive, but we think that there is a role still for massive investment needed to achieve the demand which is going to be required in these net zero scenarios. And this is the key message of this slide. So true, significant decline, but the need for investment is still there, in particular in the next 10 and 20 years. So, and this is my last slide. It has to do with carbon capture and the different uses of CO2 capture. So there is an interesting study from the Royal Society that says that no CCS, so no carbon capture and storage, no net zero scenarios. The red area that you can see here represent the amount of carbon capture in the different IPPC scenarios. BP net zero scenario have around 5 gigatons of CO2, and this is, I think, it's something that is quite not controversial, but it's quite shocking because we are not used to see or to think about carbon capture. But this is a needed technology. And the message of this chart is that if we want to achieve net zero, we are going to have in place carbon capture. And we have to see an escalation of demonstrative and pilot projects of CCUS soon. Why is there not enough political support to carbon capture today? Well, it's for me, it's not clear. Perhaps there is a problem with the narrative, but the message from the IPPC scenarios and the message from the different scenarios of CO2 is that this technology is going to be needed. This is the level of emissions of bioenergy with carbon capture and storage. These are negative emissions, so are emissions that are effectively removing CO2 from the atmosphere. And these technologies are needed because in these scenarios, some technologies and some sectors are really hard to abate. Free emissions from those sectors are really hard to cut. So we need these negative emissions, which are most likely going to be produced in the power sector, to offset emissions from, I don't know, iron, steel, cement, aviation. So negative emissions are going to be needed. Again, we have much lower emissions in the BP scenario than the IPPC scenarios. And again, this is probably because we don't see yet this type of scenarios coming into accelerating as they are needed. And the last comment has to do with natural climate solutions and perhaps direct carbon capture. We don't have this in the energy outlook, but we acknowledge that they are going to be needed also to achieve net zero. So we have to think that this type of solutions like forestation and afforestation, for example, are needed to achieve net zero. Despite they are outside the directly from the energy sector, they have to be there to achieve net zero. And with this, I finish my presentation here, and that's it.
Thank you very much, Jorge. Both presentations have been very inspiring, and I'm sure that they have been so for Alessandro and myself, and we are sure that the transitivity property applies to all our audience. Now I'm going to open the floor to Q&A, and you can pose your questions in the chat. The way we are going to do it is that you can write your questions, and I can read them and make a selection given the time constraints, and pose the questions to Laura and Jorge. So we have already something in the pipeline, and therefore I'm going to start with the following question. The question is the following, and I think is not trivial, and it is addressed to both Laura and Jorge, perhaps to Laura. You presented the energy supply pathways to net zero, but what is the role of consumer choices and preferences the energy transition to net zero? Don't you think it is crucial and at the center stage of the process? I know that it's not an easy question, but maybe you want to make you comment on this.
Thanks a lot. I think it's an excellent question. So we actually attempted to quantify the role of consumer behavior, and I think here I responded as an economist, even if I'm not an economist, I'm an engineer, but as an economist, what we defined as consumer behavior is any choice that does not leave you in the same utility function. So the fact that I decide not to travel to Hawaii doesn't leave me to the same utility function. That's a behavior change. If the next car I'm going to buy is going to be an electric vehicle vis-a-vis an ICE, that's not a behavior change. That's a technology choice, right? So what we find is that behavioral changes, so the ones I mentioned earlier, you drive slower, you bike to the office instead of taking the car, etc., actually contribute something, but it's not huge. They contribute 4% to emission reductions. And where do we find it? They make a difference, and they're interesting. They're interesting, first of all, in the short term, because the more you decarbonize, the less you care about behavioral changes, because the technology solutions are there. But in the short term, especially in the next 10, 15 years, in sector where the infrastructure is in place and you don't have the alternative, they matter a lot. Where do they matter? So to simplify this, in the transport sector, they do matter. So if you look at the 2030 time span, the fact that you decide not to fly will matter a lot. So, but overall, it is not going to be the thing that makes or break the reaching net zero. 4% of cumulative emission reduction to 2050. Having said that, I think that it's critical to have policymakers nudging the choices, meaning if we need to do a building retrofit, that's for us not a behavioral change, but if you don't have policy making that reduces the annoying part of the building retrofit, that doesn't make it cheaper, so it's an affordability question, it's going to be much, much harder. So there is around 60% of choices that could be helped by right policy design. So in short, behavioral change, the fact that you change your utility, are important in the short term, especially for transport. They are not a make or break, but policy making that designs affordability for the higher cost, lower capital cost, lower emission solutions in the short term are going to be absolutely essential.
Thank you very much, Laura. Let me move to the next question while assuring that we will try to answer all questions, perhaps separately. I'm going to ask Jorge, but the question in principle applies to both presentations. Nuclear energy has not been mentioned. Is there any role in the transition in your view, or what? Jorge.
Yeah, absolutely. I mean, it's a very good point. I mean, what happened with nuclear energy? Most of the IPCC scenarios and also BP net zero scenario has an increase nuclear energy. So I think we think all type of decarbonized sources of energy will be needed. But it is also true that nuclear energy it's highly a political and social question. So some societies will accept nuclear energy, others don't. Today, most of nuclear energy is going to be developed in China. Some countries, like for example, the UK, is now developing their own nuclear new facilities. But I mean, there is a role for nuclear energy for sure. So the answer is yes. It haven't been mentioned, but it's there.
Laura, anything that you may want to add from your point of view?
Yes, maybe. So by 2050, we have in the electricity generation, solar and wind account for around 70% of production. So you need to supply another 30% with low carbon electricity generation. And depending on the country where you are, nuclear will play a role. I think there is an important differentiation to play between advanced economies, where basically there is no, except you count them on a fingertip, how many countries in advanced economies are actually building new nuclear reactors. Completely different story, not only in China, in Russia and many other emerging economies. However, having said this, within the group of the G7, there is a very strong interest in SMRs, small modular reactors, and a lot of hope is being put into this. Whether it will work or not, but it's certainly one of the areas where there is a lot of R&D going.
Thank you. Jorge, do you think that the hydrogen spreading and diffusion will pose a problem to the availability to renewable energy sources? This is a question we received.
No, I think they are complementary. On the contrary, I mean, we have made this point about the need of having hydrogen produced from natural gas and probably also coal. But I think that hydrogen is going to help renewables to the decarbonization process. I mean, it's I don't see they are competing. I see they are complement each other. So it's.
And Jorge, again with you, BP, we noted that was expecting additional investment in oil upstream, even in the net zero scenario, more than what we have seen or from the point of view of the IEA. Any opinion, any idea where these investments are going to be concentrated geographically, for instance? Does your model foresee an increase in market power of traditional producers, or anything that you may want to say about this aspect?
I mean, it's going to be a decline in what we see is that investment logically is going to move from renewables to from fossils to renewables, and it's going to be a decline in oil and gas. I think we all agree. Where, I mean, we have a similar perception of the role of OPEC countries, that they are going to be more representative. But to say how much is going to be invested in each country, we really don't know. I think we don't have the information for that detailed analysis. So what we can say is that OPEC is going to play a bigger role because have better production conditions, cheaper in general terms. But I cannot say exactly how this is going to be broken among different regions.
Okay, this was also a question that was posed by somebody else about, you know, who will supply the residual amount of oil in 2050. And so we take Jorge's answers addressing also this question. I think it is known now right here, and to maintain our promise, I think we will conclude this webinar, and let me ask Alessandro to give you know, the few final words.
Oh, I see it is known from Laura clock behind her. So
Actually 2 minutes to noon in Paris.
yeah,
Here is 2 minutes after noon in Milan.
yeah. No, just to thank our guests and friends for their kind participation, and also thank to people in FAM that has been working for this and other occasion. So a big hug to everyone, and I hope to see you soon physically this time. I hope so. So I think we can conclude this connection in this way. Thank you very much.
Thank you very much.
See you
Ciao,
soon.
ciao.
Bye.
Bye.
Ciao.
Ciao, ciao.